The property of gases, Cambridge IGCSE Chemistry. Cambridge IGCSE covers kinetic particle theory, pressure, temperature and volume relationships, diffusion and rate of diffusion. So a quick review of kinetic particle theory. Gases are considered to be composed of particles. Those particles are very small, are solid spheres, are in rapid and random motion, and have only very weak attractions between them, if any attractions at all. Pressure effects. So the volume of a gas is affected by a pressure change. So here we have a volume of gas at a low pressure. If we increase the pressure, then we can see there's a change in the volume. The gas volume decreases. The particles, as you can see in the diagram, are closer together. The particle size does not change. It's the distances between the particles that is altered. The particles are closer together. So if we start with the right-hand side and decrease the pressure, we move to the left. Can you come up with two descriptive statements yourself? Stop the lesson, see what you can come up with, come back to check when you are ready. Okay, so if we decrease the pressure from a higher pressure to a low pressure, then the gas volume increases and the particles are further apart. It's as simple as that. Now let's look at temperature change effects. So the opening statement, the volume of gas is affected by temperature change. So here we have a gas volume at temperature T. If we increase the temperature to T plus 50, so the original temperature plus 50, we'll see that the volume increases. The particles have more kinetic energy and are further apart. Same process as the previous slide. If we start with the right-hand side, decrease the temperature from T50 to T, could you come up with some statements that describe the change? Stop the lesson, write down your ideas, come back when you are ready to check. Okay, so obviously, first thing, as a decrease in temperature, the volume decreases. That's because the particles have less kinetic energy and are closer together. A further property of gases as well as of liquids is that of diffusion. Now this describes a change whereby a gas originally in a high concentration in one region of a volume and a lower concentration in another, over time, the gas particles rearrange so that we have an even concentration across the volume. Now that is explained by the free random movement of the particles in a gas. Now Cambridge IGCSE also requires you to know about the rate of diffusion and how it depends on something called molecular mass. Now, if you haven't calculated molecular mass before, just bear with me, I'll give you the figures. But it may well be a very familiar concept to you. So if we have hydrogen chloride gas in some beads in a glass tube, forming a vapor, forming a gas, and then on the right-hand side, we've got ammonia in a similar situation being released from glass beads soaked in concentrated ammonia, forming a gas. Over time, a smoke of ammonium chloride is formed. Now that smoke of ammonium chloride is where the two gases have met and reacted. However, because ammonia moves faster than hydrogen chloride, which moves slower, the distance between the smoke and ammonia is greater. So the smoke does not form in the middle of the tube, it forms closer to the hydrogen chloride and further from the ammonia. Now, this reflects the relative molecular masses of ammonia, which is 17, and of hydrogen chloride, which is 36.5. So the lower molecular mass gas diffuses faster. The heavier molecular mass gas diffuses more slowly. So well done for finishing. If you want to do some practice questions, you'll find some, no doubt, in the end of chapter in your textbook. And if you prefer past paper questions, I suggest you go to Physics and Maths Tutor website. Nothing to do with me, just got all the past papers you could possibly want. If you found the lesson helpful, please recommend it to a friend. Please like, subscribe for updates on classes and exam tips.